Even though single sounds like it should be easier, it kind of gets a little more confusing. So in a single displacement, we don't start with two pairs. We start with a pair and one other. That's a bent arrow, meaning the yields it produces. And if it's a single displacement, what might the new ones end up like? Yeah. What happens to poor B? He's the one, she's the one, it's the one that gets dumped, displaced.
Is it always the second letter?
No. Good question. If C took the place of B, what kind of ion was C? Good. Could we have had is that possible, just based on a bunch of silly letters? Yeah. In this case, C would have been a cation. So it really all depends on what you're putting in there. What you're putting in there, right?
So how do you know if C's a cation?
Good. If I'm just making letters up, you don't know, do you? Absolutely. But if I actually pick something really off here, if I give you something off here, it'll be either in the plus column or the minus column. Or I give you the plus or minus, the charge. Okay. Great questions. Good anticipation. Now, in today's lab, you're going to put a piece of metal in with a liquid. The liquid is a solution, meaning something's dissolved. So, you go to the element store and you buy copper nitrate, and it's a blue chunky solid. It's a mineral that comes out of the earth. And then you dissolve it in water, distilled water. That's where this blue liquid comes from. So these atoms are dissolved in the water. But they are a pair. It's something like copper, nitrate. And the words aren't important to you, but you see two words, you think, oh, that's a pair. That makes sense. You're going to put a piece of metal in there. Oh, this piece of metal might be lead. The lead is going to try to displace the copper. The one metal is going to try to kick the other metal out. And if lead takes copper's place, the copper has no place to go, and it's going to fall into the test tube. So you're going to get some fuzzy, shiny, different stuff forming inside your test tube because it has no place else to go. It's homeless. It's displaced, so to speak. There are 9 different ways that they can combine. Now, just to avoid some confusion, I like to put my test tubes in little groups of 3 test tubes, space, 3 test tubes, space, 3 test tubes. Now, it's kind of cluttered underneath of there with the writing. But what liquid is in the first 3 test tubes? What liquid? Okay, what's nitrate? Lead nitrate. Okay, and that's what I'm saying. It's kind of crowded underneath there. So I'm trying to explain a little bit better than my picture is. So in the first 3 test tubes, came out. And that is the yellowish liquid over there. And about how full are you going to fill it?
1/3.
Is that very sciencey, very precise, very accurate? It's pretty sloppy, isn't it? But I'm letting you get by being sloppy. All right, lead nitrate's in there. Okay, so get one flask, bring it back, goggles on, take it back. What's another liquid you need? Copper nitrate. Copper nitrate's rather bluish. It's going to go in the middle 3 test tubes. And then silver nitrate, kind of grayish. So you have 3 different liquids. You have 3 different. So that's the words underneath. Like I said, it's a little congested in my picture down there. And then you're going to lay strips of metal. You're going to get in those little plastic tubes. You're going to bring them back to your desk. And let's say you get copper. Let's say you get copper. Where are you going to lay those copper strips? In front of what 3 test tubes? The copper.
1/3.
Does copper go in front of the first one? No? I'll make it copper. Where's it go? Come here. Come here. Hey. 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 Come here.
Remember doing like the computer?
Yeah. Would you put copper where it belongs, please? My liquid's cooperated nicely. Put 1 strip. That's copper. Where's it go? Alrighty, right there. The CU stands for copper. And then where's the next piece of copper go? And a 3rd piece. Alrighty. And then lead goes in front of 1, 4, and 7, etc. Alright, so you're going to get it all ready to go. So you're going to have your test tubes full of liquids. You're going to have the metals laying on the table in front of them. And then once you get everything set, you're going to get me over there and I'm going to say, perfect, put them in. Fair enough?
Do we do one at a time?
And then we'll react for a few minutes, take a goggle break, come back, and then we'll use that big chart to write them in, but don't start writing right away. All right, since we got room, why don't we just all kind of move over to this side, to the lab side. We're going to give them a grade. Now, as long as you aren't shaking your test tubes all around, if you want to slip your goggles off, I think you'll be okay. Of your 9, you're going to need a test tubes in front of you, ladies. You can bring them to your table. If you were the teacher and you were giving the best test tube the highest grade, which test tube would get the A+, in your opinion? You may be different. Who gets the A+? You're going with number 9. And you may be different. 2. So on this next page, you see kind of like what I have up here. So you're going to grade them. And I would grade your 2 or 3 or 4 highest first. You got an A+, maybe you got an A, maybe you got an A-, maybe a B+. So grade your 3 or 4 highest. So for test tube 2, you would give it a grade, an A, B, C grade. And since you're calling it the most active, you're going to give it the A+, aren't you, Brooke?
Yeah.
You say, all right, that's my A+, in her opinion. You may not agree. Okay, so do your 3 or 4 most reactive, please.
I just started going down.
Be careful of your numbers. There's a reason I mixed them up in this order. The reason I mixed them up in this order. Bless you. Do your 3 or 4 highest. I typically think there's 4 of them that are pretty.
Wait, are we only giving out A's right now?
It's up to you. If you think one's a B or B+. So I'm saying your 3 or 4 most reactive, in your opinion. And yours may be different than somebody else's. Are they all equal A's?
Yes.
Okay, it's up to you. Now my next suggestion is go to those kids who aren't, or they're refusing to do anything. What grade do you give those kids? All right. so those test tubes that did nothing. Which one are you gonna flunk? 3?
1.
Here, man, out. Wait a second. Man, you guys are brutal. So you might have 3 or 4 that get F's in this little silly system. And then go back and fill the others in. Maybe they are B's and C's and D's. So when you're done, all 9 got a grade. You might be a real strict teacher, you might be a real lenient teacher. It's your turn to play teacher. Let's go on Candace. Candace, would you read me your 1, 4, and 7? Your first column, please.
F, D, D.
The window's being loud over there. D, then dog,
Yeah,
and a B. If we average that, what is that? About C minus, D plus, something like that? Okay. We're going to average the next column. You're going to average the next column.
Me,
All right? Everybody's going to. Just what do you think your average is? Now you may not agree with Candace's C minus, because your test tubes are not exactly like
I
hers.
think that should be an
All right. So when you added this up, you're going to give us this whole average today. That must be your.
That's really weird because I have the same things for the first one.
Everybody want to give me their average on this row?
Yeah. Well, I have 2 F's and a B, so.
2 F's and a B. Maybe like a D plus or something.
What if you had an A there?
Then there might be a C minus. Yeah. It's like their GPA. And is it weird that yours is fairly close to everybody else's in the class?
No, we did the same thing.
We think that. I would think they should be about the same, right? Okay. Let's talk about number 1. Flunking. No replacement, was there? Well, what was the metal? Let's go back, look at my picture. What was the metal in test tube 1?
Lead,
Lead. What was the liquid in test tube 1?
lead nitrate. They can't replace themselves.
Nice answer. So nothing happened. Huh. So sometimes there'll be a reaction, sometimes there won't be a reaction. Called the reactivity series.
I have a question.
Fire away. Good anticipation. I think there's 15 different ions in that list. Once you lay your pencils down, I think there's 15. And scientists around the world did exactly what you did. Only they didn't use just 3, they used all 15. And they have said of all the reactants, of all these metals, potassium, K, is most, in fact, we had some little pieces of potassium, didn't we? And we put them in a great big beaker of water. What happened back there?
The sparks.
Yeah, it set off sparks and it got hot and whatever. What if I'd say, oh, let's put a piece of potassium in one of those little test tubes? What would have happened? You're darn right. Because it's confined to the, you notice I did it in great big beakers on purpose. Lots of cold water to absorb the energy. If we'd have dropped a piece of potassium in that little test tube, and it got so hot that it would probably shatter that glass.
Can we
So
try
that's-
it again?
No!
I think it'd be cool to watch. It would be really cool.
It would be. But it'd be dangerous if something bad happened. I'd be in trouble. But I appreciate your enthusiasm. All right. Oh! They said the second most reactive is something called Sodium. I think we had sodium, didn't we? What happened? It turned hot. It made sparks. So why didn't we use sodium? It's a little too dangerous for me to let you do that. We did magnesium. They all were a little too violent for us, all right? But my point is, you just did what the rest of the world's done, and so far, let's see how we agree. We had zinc, we had lead, and we had copper. And how many of you said zinc of the three we had was the most reactive?
All of us. Yeah.
Ta-da! So do the experts of the world. What do you got? Now, these are very close together. There's not a world difference. How many of you had lead in second place? Okay, 3 out of 4 ain't bad, as they say. Because they're so close, you might have had a little slight difference of opinion. Now, here's the deal. In order to displace, you have to be more reactive than what you're trying to replace. Are you with me?
That you're more reactive than
Yeah. Would I be on the left side of this chart, or would she be more to the left in this chart? Yeah, okay. So, could Fe displace Sn?
Yeah.
Because it's more reactive. Could Sn displace Fe? Nope. It's a little bit on the wimpier side. A little bit on the wimpier side. With that in mind, how about we skip 2 and 3 for now, and do 4 through, what is that last number, please?
9.
9. If you would do 4 through 9. So with that in mind, we go to the next page, and it's about this, it's very similar. There's your reactivity chart again. And if on this first case, K, who has the partner to start with? AU. AU has the partner to start with. In comes K. Here comes Carl. Is he really more reactive? He's super reactive. What about AU? Wimpy, wimpy, wimpy. So, are we going to dump AU for K? In a blink. You talk about a reaction. So if they're real far apart and on the proper side on the left, there's going to be a very big reaction. The further apart, the greater the reaction. That's why we did not use potassium, sodium, and magnesium in this little test tube.
Okay, well,
All
I
right.
want to show it
If they would just be 1 or 2 apart, I would choose some. If it was nickel trying to replace tin, nickel's on the left side, so there would be a reaction, but probably not very much.
less reactive, try to replace
Then
more
it's not.
reactive.
That's where they're not. Okay. Do that section, please. Great questions, as always.
Will you check it? Or you're gonna go over the-
We had silver nitrate at number 8. And what piece of metal did you slip in number 8? I forget.
On 8,
8.
zinc.
Zinc. Okay. If you look at your chart, zinc is more reactive. So what does zinc do to the silver? Bam! Threw it out of its chair, took its spot, displaced it. The new liquid is zinc nitrate, and these arrows, falling out is poor silver. Silver got kicked out of the liquid. Silver got kicked out of the liquid. So,
Does the metal eventually start to dissolve?
there's the silver atoms that was in the liquid, had no place to go, so they just started piling up on that piece of metal. So there's about $5 worth of silver there.
Why don't you say that?
Well, sometimes you kind of do. All right, now, Taylor asked the very important question, well, but what's happening to the piece of metal? Okay. You get that piece of metal left, Brooke, that we've not tapped out? What is happening to that strip of zinc metal? What's happening to some of the atoms on the outside of it? Where is that zinc going? Into the
Atoms.
liquid. It's the metal, and it's not dissolving. It's reacting. There's a difference. It's not dissolving, it's reacting. So some of the zinc, if you left that in there long enough, the metal would eventually all be gone. Yeah, all right, good questions, because that's what the confusion is. Some of the liquid atoms are getting kicked out, and that's what you're seeing as the fuzz, as the moldy stuff.
Ooh, this one's actually really good.
Some of the metal is getting thinner, and it's becoming the liquid.
Could you reuse these metals and they work the same?
Okay, so here's what we do when we're done. I'll count, since you guys can handle it, I'll leave it up to you. Typically, I say dump everything into here, clean your test tubes out. Don't go telling everyone. If you would like to